Yeah. So let's talk about this. First, talk about this web search, and then we will talk about this representation learning. So the web search is just give you this, good example to show, in fact, how you can actually make use of this. So this search problem is that think about this is you got this input which is like a query, right? The query could be anything, right? Could be like a set of keywords, or could be like a question, like let's say general sense. You want to find the answer, so you can think about this as sort of X. Again, you have this function, and you try to come in with a Y. So here the Y is the you can think about this as a in the question answer kind of case, would it be this X be the text about certain question and Y could be answer. But in the ranking based web search could be some sort of like an X could be X and Y pair, okay, and the output would be the ranking of of X given Y. Or so in this case, Y could be the query, right? The X could be the document. So in other words, you have these two sort of input and one single output. So the way to do it is that you can actually map this to a representation space, and then do something around that. So remember, what we got is in this neural network, you can create some sort of embedding in the embedding layer. From that, you can have a comparison with it. So this search problem then therefore can convert into, say, I got this query, I got this document, then I build this sort of embedding to the low dimensional space, and with somehow to measure this relevancy between this query and document. This relevancy can be done by using, for example, cosine similarity if we are in this low dimensional space, right? And this is typically people using this letter trigram rather than words to represent this the tokens, and that is said to be like in terms of vocabulary space would be much low, and you don't have this out of vocabulary problem. So once you building that kind of representation, and you can then specify sort of this embedding to it and create this neural network, and then construct this low-level representation in this in that space, and you can actually calculate the similarity. So this could be this sort of a positive examples, and this could be negative examples. Then we want to make sure that I would have this parameter representation, neural network parameter, to form this representation in such a way that these two more relevant ones are too close in that space in terms of cosine similarity. The one that a negative example are away from this cosine similarity measure. So then you have this kind of measure, and you want these two are close together, you want these two are far away from it, and using that to backpropagate this neural network. So once you have that, then you were able to sort of construct the kind of representation. This can be, again, trained in a sort of end-to-end fashion, right? You don't really need to have this like a previously sort of stack them together and build it low dimensional, rather than, because this relevancy, you will have a judgment for that. So that basically shows there's a certain semantic meaning of those representation. So the interesting of this is that you can do a lot of different problems, not just the web search, right? You think about this, there's X and Y, and you try to find the relationship between X and Y.